Hypothesis tests are used to make inferences about the population under study. In the realm of statistical analysis, selecting an appropriate test for your data is crucial to drawing accurate conclusions. T-test, Z-test, ANOVA are the parametric test, and chi-square test is a non-parametric test. These tests form the backbone of many statistical analysis, providing robust methods to compare groups, examine relationships, and test hypotheses. So let's look at them one by one. T-test was introduced by William Selly Gossett. It is a parametric test of hypothesis testing based on student t-distribution. It is used when sample size is small, that is less than 30, and when population standard deviation is unknown. Mann-Whitney U-test is the non-parametric equivalent of the two samples t-test, while Coxon-Sinrine test is the non-parametric equivalent of the one sample t-test. Assumptions for t-test are parent populations follow normal distribution, both the population have equal and unknown variances, and the samples are random. One sample t-test compares sample mean with the population mean. Two samples t-test compares means between two independent groups. Paired samples t-test compares means within the same group at two different times. Decision criteria is to reject H0 if T statistic is greater than table value. If the null hypothesis is true, then we can say there is no difference between the sample mean and the population mean. Data should involve a continuous dependent variable and a categorical independent variable with two levels. Z-tests are a fundamental tool in statistics and are helpful for making data-driven decisions. It is used to compare sample and population means or compare proportions. It is similar to a t-test but used when the sample size is large, that is greater than 30, and population variance is known. In t-test, we assume population variances are unknown, but in z-test, we assume population variance are known and rest of the assumptions are same. One-tailed test is used to see if the sample mean is higher or lower than the hypothesized value. Two-tailed test is used to see if the sample mean is simply different from the hypothesized value without specifying a direction. Decision criteria is to reject H0 if Z statistic is greater than table value, or we can just compare p value with the level of significance. That is, we will reject H0 if p value is less than level of significance alpha. And if the null hypothesis is true, then we can say there is no significant difference between the sample and hypothesized value. ANOVA stands for Analysis of Variance and it is an extension of t-test. ANOVA is a powerful tool for researchers and analysts in various fields. It helps to understand how different factors influence outcomes and whether observed differences are meaningful. ANOVA compares variations of the factors to see if the difference between group means is statistically significant. It analyzes the difference between the average values of several groups. It is used to determine if differences in means are due to random chance or reflect genuine variations between the groups. Assumptions for ANOVA are parent population follow normal distribution, samples are random and independent, the various effects are additive in nature, and homogeneity of sample variance. One-way ANOVA contains one factor or independent variable. It compares three or more levels of one factor. It is used to see if a new fertilizer type affects plant growth differently across three groups planted with different amounts of fertilizers. Two-way ANOVA is an extension of one-way ANOVA. It contains more than one factor or independent variable. It compares the effect of multiple levels of two factors. It is used to study the effect of fertilizer type and sunlight exposure on plant growth across various combinations of these factors. ANOVA breaks down the total variation in the data into two parts as shown in the table. Chi-square test is a non-parametric test. It is given by Carl Pearson and used to test whether a given set of observation follow a specified distribution. Chi-square can be used as a test of goodness of fit and as a test of independence of two variables. It makes the comparison between the expected and observed frequencies. If the null hypothesis is true, then expected frequencies will not differ much from observed frequencies. Here, chi-square statistics follow chi-square distribution with n-1 degrees of freedom, where n is number of categories. If we are comparing eyesight, poor or good, with gender, male or female, then n will be 2. These are some examples where we can use chi-square test. And that's it from my side. Thank you.